All right. So we're going to write an equation of a line in 3 dimensions, and of course, if you can do it in 3 dimensions, you can do it in 4 and higher dimensions as well. So let's say we have 2 points in space. Give me some coordinates. Point A, point B. What are good coordinates for point A?
1, 1, 1.
1, 1, 1. Okay, we'll go to 1, 1, 1. And what about B?
2, 2, 2.
2, 2, 2. Come on.
3, 3, 3.
No, come on. How about 3, 4, 5 at least? Okay, how do I write the equation of a line in 3 dimensions that goes through these 2 points? Well, to write an equation of a line, you need to know a vector that points in the direction of the line, and then you have to know a point. Well, we got 2 points, so that's easy. Now, can you see a vector that points in the direction of the line? Well, I see 2. How about vector AB or a vector BA? Yeah, either one. Pick one. Why don't we go vector AB? Now, componentize it. You guys should be good at this. How do you componentize a vector? You go head minus tail. So what is it? 3 minus 1, 4 minus 1, 5 minus 1. How creative. Okay, so there's an infinite number of ways of writing an equation of a line. It just depends what point you pick, because this line is made up of an infinite number of points, and you just need a vector that points in the direction of the line, but there's an infinite number of vectors that point in the direction of the line, right? Could be AB, could be BA. What about half of AB? Or 2 times BA? Okay, so let's say I use this point and I use this vector. Watch what I do. It's very simple. X equals 1 plus 2t. Y equals 1 plus 3t. Z is equal to 1 plus 4t. These are the parametric equations of the line. Where did this 1, 1, 1 come from? That's from the point. Now, you could have easily used this point, so you could have had 3, 4, 5 here as well, or any other point that lies on the line. And where did this 2, 3, and 4 come from? Those are the components of the vector, but if it was a different vector, then you would have different components here. So it just depends what point you pick and what vector you use. As long as the point is on the line and the vector points in the direction of the line. Now, do you see how this one works though? What happens when you plug in 0 for t? Plug in 0 for t. What do you get?
1.
You get 1, 1. So the particle is here. The way I wrote these equations here, the particle is here at t equals 0. And then what happens when you plug in 1 for t? What do you get?
1.
You get 3, 4, 5. So here is the particle 1 second later. To me, that's the simplest way to do it. But like I said, there's an infinite number of ways of doing it. This is the simplest way. Now, what does the rectangular equation of the line look like? How do you get rid of the t? Well, solve for t in the first equation. Can we do it? Just solve for t in the first equation. Move the 1 on this side and then divide by 2. What do you get? X minus 1 over 2. Solve for t in the second equation.
1.
Y minus 1 over 3. And then solve for t in the third equation. Z minus 1 over 4. And would you agree that t equals t equals t? So therefore this equals this equals this. This is the rectangular equation of the line. That's kind of weird, yeah? But this is what an equation of a line looks like in 3 dimensions. If it were in 4 dimensions, you would have equal something else there as well. So these are the parametric equations of the line. These are the rectangular equations of the same line. And again, look, 1, 1, 1, that's the point. 2, 3, 4, those are the components of the vector. 1, 1, 1, that's the point. 2, 3, 4, those are the components of the vector. Okay, so some of the problems on tonight's homework, you just have to write an equation of the line. But then, by the time we get to the test, which is very soon already, I'm going to ask you, where does this line intersect some graph? Okay, what graph do you want to do? A plane? Okay, here's a plane. So here's a line in space. It hits this plane, and then it keeps on going, right? At what point does it hit the plane? Give me an equation of a plane.
2x
minus
3y
minus 3y
plus 4z
plus 4z equals
3.
3. Okay, let's see if it comes out nice or it comes out ugly. I'm gonna make mine come out nice. So, here's the equation of the line. This is the parametric form. This is the rectangular form. This is, I wanna figure out where does this line intersect this plane. So which one do you think I should use? Should I use the parametric form or should I use the rectangular form? Which one is the easiest one so that I can just plug it into here?
Parametric.
It's a 1 out of 2 chance, people.
Parametric.
This one right here. So if you just simply plug in these numbers for x, y, and z, not numbers, but expressions for x, y, and z, then you're just gonna have an equation with t in it, and then you can solve it, right? Okay, so let's do it. So plugging in the parametric equations, you get 2 times x, which is 1 plus 2t, minus 3 times y, which is 1 plus 3t, plus 4 times z, which is 1 plus 4t, is equal to 3. Come on, you can take this down to the 8th graders. They can solve this, right? This is algebra 1. In fact, it might be even pre-algebra. So multiply it all out. 2 plus 4t minus 3 minus 9t plus 4 plus 16t is equal to 3. Add all the t's up, what do you get? 11t. Add all the numbers up, you get
12.
3, huh? So you get 3. Oh, it came out nice, equal 3. So therefore 11t equals 0, which means t is equal to 0. That means when t is 0, that's when it's going to hit the plane. So how do you figure out the exact point?
Plug in.
You plug in 0 into these equations here, and what do you get? You get 0. No, you don't get 0. You get 1, 1, 1. That means that's the point where it hit the plane. Okay, obviously I'm not going to do that for a quiz or test, but that's the way you would do it. In fact, by the time we get to the test, I'm not going to make it a plane. I'm going to make it like a sphere or something. So think about it. If you have a sphere and a line goes through it, then you have like 2 points of intersection, right? Or maybe I can think of a graph where you have 3 points. And then you can do synthetic division. You guys love doing synthetic division anyway, right? Why did I expect the response? Okay. So that's easy enough. And then the second half, see, look at number 4. Where does the line intersect the plane? It's exactly the problem we did here, the different numbers. Okay, and then the next thing, I discussed some very important graphs in mathematics. Did Mr. Rubash talk about the cycloid last year? Because in previous years, they told me that he loves to talk about the cycloid. Okay, well, it doesn't matter, I'm going to tell you now. Maybe I should just look for something on YouTube, it might be better. Okay, so what would happen, okay, so here's a circle, yeah? And there's a point on this circle. Let's get a line. So you gotta imagine this as a circle, and this is a line. So you see the point that I have there? See this point? What would happen if I roll this circle on a line without slipping? That's a term from physics. You guys know what that means? Without slipping? You know, slipping is like this. You gotta roll it without slipping. What is the path traced out by this particle right here? Well, okay, let's see if I can hold it. Okay, I'm gonna roll it. So just watch that point right there. Keep your eye on the black point right there. Oh gosh, it's moving. What the heck? Why don't you we'll just tilt it and then let it go. Let's do this then. Oh. Did you see the point? So if like you roll it on the x, here's the x-axis, here's the y-axis. So let's say you have a circle. Doggone it, that's not a good circle. Okay, right there. Okay, here's that point. If I roll the circle on the x-axis without slipping, what is the path traced out? Did you guys watch it? What did it look like? Did it go something like this? on going, right? We call this a cycloid. Okay, there's a reason why I put these on the homework now. You're probably going to see them again on the test. Okay. Now the interesting thing about the cycloid is if you invert the cycloid, like turn it upside down, it has a really interesting shape here. So, what if there was a contest for physics? I don't know, maybe you guys do it in physics. So every student is given like a marble, a ball bearing or something, and then you have to build a path that'll get the ball from here to here, or just here to here. What kind of path should you build? Should it just make a straight line, like that, and then release the ball? Is it gonna get to that point in the fastest amount of time? No, it's not. You know what the fastest is? It's an inverted cycloid. You make it like this. That's because at the very beginning, see, this is like almost vertical. In fact, it is vertical at the very beginning. Because over here, look, it's not vertical, so it's going to take a while to pick up speed here. But since this is vertical right there, it'll get there in the fastest amount of time. So if you want to win that contest, you take the cycloid and turn it upside down. Another thing about cycloids is, what if somebody had a marble here, let's say this is an upside down cycloid, and somebody, in fact, what if it's not there? Somebody's going to release a marble over there, somebody's going to release the marble over here. Which one gets to the bottom the fastest? They get there at the same time. That's another amazing thing about the cycloid. Okay? So those of you who had Mr. Rubash, did he talk about that? How come one person is going no and one person is going yes? What is going on? Whatever, I told you what one of the, these are two of the properties of the cycloid. And, I guess, I don't know how much, we better erase this. What would happen now, let's say you have a circle. And then you have another circle that's 1/4 the radius of this. So that's the radius I have, something like that. Like this. Okay? Now what would happen if you, okay, so this circle is 1/4 the radius of the big circle. Now look at this point. What if I were to roll the circle on the inside of the bigger circle without slipping? What would be the path traced out by this point? Can you imagine? Roll it. What would happen? You would see something like this. This is a very famous graph in mathematics. In fact, you're going to graph it on your homework tonight. It's called the hypocycloid of 4 cusps. So now you know what a cycloid is. This is a hypocycloid of 4 cusps. You guys know what a cusp is? A cusp is like there, when a graph comes to a sharp point like that. Now, this is not on the homework, but I think I should tell you this. What would happen if you have a circle that's 1/4 the radius of the big circle? Here, let's do another one. But we're going to roll it on the outside of the circle without slipping. What would happen? So what would be the path traced out by this point right here? If you roll this on the outside of the circle, what do you think it's going to look like? Roll it. It's going to look like this. You know what we call that? Come on, if this is a hypocycloid, this one will be? No.
Cycloid.
Every year the students say that. Here, I'll give you a hint. Maybe you gotta know Latin for this. Who takes Latin? I always ask that question and I get no response. No response. Some of you, I bet you take Latin and you're holding out on me. That's what I think.
T. R.
cycloid. Does that make sense? Epidermis, outside the skin. Anyway. Okay, and then last thing, look at number 7 on tonight's homework. I'm going to tell you right now, this problem is on the test. Okay? Except instead of 4, you're going to have 8. So I'm going to give you 8 equations, and this one you only get 4, and you have to match it with the graph. Hey, I just thought of a good problem. Just make more graphs than there are equations, so you got to think more. Now, this would be easy if you had a calculator, right? You just take out your calculator. You guys know how to graph parametric equations on there. But you're not going to get a calculator. What are you going to do then? So look at the 4 graphs that I gave you. Okay, what does the first one look like? It looks like a cloud. Is that a cloud? Okay, the second graph looks like, what is this? The third graph looks like this. Looks like a lemniscate almost. And then this one is like a musubi, yeah? You guys know what a musubi is? Okay, now here are the equations. The first one is, oh gosh, I can't read it. Is 4 something? Can somebody read it to me? And y equals? Here, you know what? Let's take a challenge. I'm going to see if I can 5 something. X equal 5. Let me just guess what I think it is. Sine t minus sine 2t. Is that right? Just tell me if I'm wrong. Y equals 3 cosine t plus cosine 2t. Okay, C is, oh my goodness, x equal 5 cosine t minus cosine 5t. And then y equals, 5 sine t minus sine 5t. And then finally d, I'm getting farther away, 4 sine 2t, that's my guess anyway. And then y equals 4 cosine t. Did I get it right? Yeah. Okay, match the graph with the equation. So on the test, you're just going to write the letter of the equation next to the graph, except there's going to be 8 of them. Okay, how would you do this if you don't have a calculator? Come on, by now you guys have a general idea of how parametric equations work. Okay, should I just tell you? Plug in numbers for t. Plug in numbers for t. Okay, so like, okay, here are the 4 equations. I don't know, make some kind of chart or I don't know. What would be like the easiest number to plug in for t? 0. Okay, so like plug in 0. What point do you get for this one?
0.
No.
Undefined.
Undefined.
And 0.
0. So undefined, 0. Okay, what about the next one? Plug in 0 for t.
0.
0.
Undefined.
No. Cosine of 0 is 1. Okay, if we cannot even plug in 0, what prayer do we have for
3.
plugging in like 5 or 6?
4.
Okay, 4. Oh, now you guys think you can do it. Okay, plug in 0 into this one. Okay, I'll give you a hint. Cosine of 0 is 1.
5.
No. Are you serious?
Oh, 4.
You cannot be serious! Bro, we cannot plug in 0. Okay, 4, comma.
0.
Okay, and then plug in 0.
0.
0, comma.
4.
Okay. So, this first one, undefined. Remember what did we talk about last time? If one of the equations becomes undefined, what does it do? It explodes infinitely far away. That's what happens. There's only one graph here that goes infinitely far away.
Number 2.
That's that one right there. So this one since it's undefined, this one has to be A. You guys understand? Because it becomes undefined at zeros, and therefore the graph has to go infinitely far away, explodes out there. But you can probably guess on the test, not gonna just have one. See, like right here, there's only one graph that goes infinitely far away. But probably on the test, probably gonna have 2 or 3. Because really, do I want you to get the answer just by plugging in one number? No, I don't want you to do that. I want you to plug in at least 2 or 3 numbers. Okay, so we already determined that one, so now what? This graph passes through 0, 4. Does that help us?
No.
No, because look at these 3. Isn't this point 0, 4? Isn't that 0, 4? Isn't that 0, 4? Wait, let me go up close and make sure. Yes, they all pass through, the other 3 all pass through 0, 4. So that doesn't help. What about 4, 0? What about 4, 0? Well, that's 4, 0. Okay, this one is not 4, 0, because 4, 0 is here. And then what about this one? Does the Musubi pass through 4, 0? Okay, wait, I gotta go and check again. Yes, it does. So, at least we narrow down something. What can we figure out? Because this graph does not pass through 4, 0, so this equation cannot be this third one then, yeah? How shall we mark that? Maybe we should go. Maybe we should do this then. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. I don't know. I'm just trying to figure out something. Maybe you guys can figure out something better. So we already know this one is A. So we know the second graph is A. So you know it can't be 2 because it's already taken. But this equation cannot be the third one, right? Because it doesn't pass through the point 4, 0. So this one cannot be 3 then. How about this then? Process it, how do you guys want to do it then?
Find the whole point.
I wish I could just use my calculator. Okay, now we need to plug in another point. What number should we plug in for t?
Pi over 2.
I'll let you pick it. You want to go with pi over 6,
Pi
pi
over
over 4, pi over 3, pi over 2?
Yes.
Quadrantal angle, that's what I would do. Okay, so plug in pi over 2.
Wait,
Now, do we even have to do it for this?
No.
No, we already know this one already, okay? Let's do it here. Plug in pi over 2. What do you get? I don't know, judging from what I've seen before, you guys had problems just plugging in 0. What pair do we have in pi over 2?
5.
5,
5.
okay, 5. I agree. And then? -1. Can we do anything from that? Does this graph pass through the point 5, -1? Yeah, it kind of does. What about this one?
No.
No, so this one cannot be the third graph. Does this graph pass through the point 5, -1?
Possibly.
Yeah, it looks like it, yeah. Okay. Okay, well, at least we eliminated that one. Okay, what about this one? Plug in pi over 2 into this. What do you get?
9.
What? I'll give you a hint. Cosine of pi over 2 is 0.
What's the cosine? 0.
Is 0, comma. Sine of pi over 2 is 1. 4. Okay, thank you. Yeah, but Mr. Park, how do you compute the sine of 5 pi over 2? Well, reduce the angle down to something that you can work with, right? Subtract 2 pi from it, you get pi over 2. So you get 5 minus 1, 4. But that doesn't really help because, like I said, all the remaining graphs pass through point 0, 4, right? Okay, what about this one? Plug in pi over 2. What do you get?
0.
Okay, 0, because sine of pi is 0.
4.
And cosine of pi, now, we can do something with that. Which of the remaining graphs pass through 0, 0?
Number 2.
This one does, but these two don't, so don't we know now that this is D then? Right? Because the other two don't pass through 0, 0. Okay, we're getting there. Why am I doing this all for you? Okay, you guys need to finish it. I can't believe I fell into your web of deception. You guys are sneaky, huh? You guys just let the teacher go. Mr. Park, we need to practice this. Yeah, you're right. You guys do need to practice it. Okay, one last thing. or maybe I'll just give you 2 points. I don't know. I just don't know. But what you have to do is you have to be able to find the distance between a point and a line in 3 dimensions. Now, can I use the formula we used in 2 dimensions? No, that only works in 2 dimensions. This is in space, that's why. Okay, I'll give you the parametric form of the line then. How about x equals 2 plus 3t, y equals 3 plus 5t, and z is equal to 5 plus 8t. Put some Fibonacci numbers in there like that. Okay, and give me a point that's not on the line. Give me the coordinates of a point. Here, knowing you guys, 1, 1, 1. Find the distance between the point and the line. Now, when we talk about the distance between a point and a graph, we look at the shortest possible distance. Like that. The shortest possible distance now. The perpendicular distance. How would you do this? No, of course, you go on the internet to have formulas, but you gotta understand what the formula is saying. I would highly suggest don't memorize the formula. Just do what I tell you to do here. You can do it. Okay, I'll give you a hint. Make a triangle. So you make a triangle out of this point and any 2 points on the line. Any 2 points, doesn't matter. Okay? That way you have a triangle, and what is this distance that we're trying to find? Isn't that the height of the triangle? Yes. So, isn't the area of a triangle 1/2 base times height? We're trying to find the height. So what we need to do is find the area of the triangle. Hey, we did that on the last test. And then find the base. Can we do that? Yeah, we did that on the last test. Yesterday, or the day before, wherever it was. So what you do is, you find 2 points on the line. Now, a line is made up of an infinite number of points. Can you find 2? Okay, what would be 1 point right here?
2, 3.
Yeah, just 2, 3, 5. Plug in 0 for t. To me, that's the easiest. 2, 3, 5. And then what would be another point on the line?
5, 8, 12.
Yeah, I'll plug in 1 for t. Now, if you want to take the challenge, how about plug in -7/3 and 15/17 for t? Yeah, that will work, except you're going to be working with fractions, right? So why not plug in the 2 easiest numbers, 0 and 1? So when you plug in 1, you get 5, 8, 13. Okay, now, how do I compute the area of this triangle? You guys did this on the test. What's the fastest way to compute the area of a triangle? Half the length of the cross product. So, what you do is you form these 2 vectors. We still gotta do vectors? Okay, form these 2 vectors. In fact, why don't we call this A, B, and C so you don't get confused? Componentize vector AB. Come on, head minus tail. What? AB? 5 minus 2.
3.
3. 8 minus 3.
5.
13 minus 5.
8.
Okay, now componentize vector AC. Head minus tail. 1 minus 2. 1 minus 3. 1 minus 5. Half the length of the cross product is the area of the triangle. So, how do you compute the cross product again? Oh, I don't know, I purged it already. IJK 3, 5, 8, -1, -2, -4. Now you guys are good, come on. Hopefully, let's go straight to the vector already. So if I expand across the first row, cross out the row and column, -20 plus 16.
-4.
-4. Cross out the row and column with the J, -12 plus 8.
-4.
-4, but it's in the negative position.
4.
4. And then finally, cross out the row and the column with the K, -6 plus 5. -1. So, what is the length of the cross product? It's the square root of this squared plus this squared plus this squared. 16 plus 16 plus 1.
√33.
So therefore, what's the area of the triangle? It's half of that. So it's √33/2. Hey, we got the area. And that's equal to 1/2 the base times the height. Now, here's the base, which is vector AB. Do we know how to find the length of a vector? Yeah, here's vector AB. How to find the length of it? It's the square root of this squared plus this squared plus this squared. 9 plus 25 plus 64.
108.
Okay, I don't know. I would add, look, 34 plus 64.
98.
Root 98. Hey, we can simplify that. That's 49 times 2. 7 root 2, because some of you don't like simplifying, it looks like. So this is 7 root 2. Multiply both sides by 2. Therefore, the height is equal to what?
Root 33.
Root 33 over 7 root 2. Is that acceptable? Yeah, because you can't do any canceling. So that would be good. Of course, I'm going to try and make mine come up nice. Like 5 or something. So that's how you find the distance between a point and a line in 3 or higher dimensions. You form a triangle. Area of a triangle is 1/2 base times height. You're trying to find the height. So all you gotta do is find the area, which is easy to do, and the base, which is also easy to do, right? It's just the length of the vector. Okay? This problem is on the test. You just gotta prove to me that you can do it. But who knows? What if I don't give you the line in this form? What if I give it to you in rectangular form? Are you gonna be able to do it? Oh, find out, won't we? Alright, so I have nothing left to teach you for this chapter. You just have to hone your skill. The biggest part of the test is going to be last night's homework. I think out of the 8 problems on the test, 5 of them are going to be just like that, just like tomorrow's quiz, except tougher. You know what I'm talking about?